Okay, ASL here. I'm going to talk about homoiconicity, specifically in the language Lisp, which is a popular proponent of the concept. Um, Essentially, Lisp is an old language. It's the second oldest high-level language next to Fortran. Does a lot of Lisp processing. That's where it gets its name. Um, so homoiconicity is is sometimes a a controversial subject to to a lot of people. I mean, a lot of people can't agree on it because the definition can be a little abstract, can be wavery. People also, a lot of people seem to think that it's not a very useful definition, um, which is commonly defined as when the syntax of the language is the same as the syntax of its data structures, which makes it possible to read without parsing. Um, but an easier way to think about it is just that the code is data. The code can be run as is. It can be seen as metaprogramming, as code running code. Um, so I'm gonna start with an analog in Java. We'll just say this is a valid statement in Java. It's syntactically correct. Um, so this is not in Java, but this is kind of what what is happening in Lisp when homoiconicity is performed. So we have this kind of wrapped around this other statement. This other statement runs code in itself, and then of course the invocation. I don't think that's how you spell it. I think that is gonna be, just that. And then that's going to create the string s, new string hello. So, alright, so I have putty here. Um, so we're gonna open CLisp, common Lisp, an implementation of Lisp. We're gonna see just a couple things, keep it kind of basic. So right now we can see that a list can be defined using this macro setf. We'll say L1, 1, 2, 3, 4, 5. Alright, see this is a function, creates this list. Setf is this macro. It's taking this function argument, and this other function, L1, now represents list. Now, we can go ahead and change that. Setf car returns the first element of the list. We can set it to the multiplication symbol. Now when we look at L1, we see times 2, 3, 4, 5, which is interesting, an operator as part of a list with operands. Now we evaluate those lists, we go ahead and get the product of all those numbers. So I want to show how you can set a new predefined, I don't know if we'd call it function, I think so, to be that. So let's set that back. Let's set that back. First element of L1 is back to 1. Oh, by the way, the single quote is kind of like a interpret literally. Don't evaluate. So it's like a Yeah, like if you would wrap a char or a string around that. And then numbers, we don't need to do that. So we can go ahead and see that we set that back. So it's back to 1, 2, 3, 4, 5. And then, so we can create with this macro, we can say change first. I want to change first. I want change first to be this quote is this literal interpretation of set f, the first element, to star. Alright, now we see we get returned this string, that's instruction, that's code right there, right? But we didn't run this code. Instead we told it to be contained in this change first. If we look at change first, it's that. If we evaluate change first, it does that evaluation. Now we can see, we can evaluate the list, and we get that. So that's a basic demonstration of homoiconicity. Thank you.